demonstrating some of the basic functionality of the Project Crystal Blue clients for Mac OS X and iOS. Project Crystal Blue, or PCB, is a software package designed for cataloging geological rock and soil collections. We will show you how you can import your existing data, add new items, modify data, manage lab procedures, and more. And you'll even see how data can automatically be synchronized between a Mac computer and an iOS device. We'll start out in the Mac OS X client. When you first launch the application, you will be prompted to enter in Amazon login credentials. Since we've launched our application before, we just have to type in a local password to unlock the credentials stored on this machine. Currently, our library is completely empty. We'll fix that by importing some of our existing data, which we have previously managed using spreadsheet software. All that we had to do was change our column headers to match those attributes expected by Project Crystal Blue and export the spreadsheet as a CSV file. Now the program can automatically import our data. Let's try it now. Now let's take a look at this data that we've just imported. On the main screen, we are viewing the sources that we've collected. The term source refers to any collection of objects that we've collected while out in the field. For example, a collection of rock fragments from the same outcrop that are all the same composition would collectively be considered a single source. In contrast to a source, a sample refers to a sample taken from a source, usually a fragment taken for laboratory analysis. We'll look more closely at samples later. For now, let's just look at a source in more detail. In addition to viewing information about a source in the main spreadsheet view, there is also a detail panel on the right side of the screen that displays the various attributes associated with the selected source. We can also click on a Google Maps link to see the location at which this source was gathered. For example, this particular source was collected in Antarctica. Now let's see how we can make changes to this data. Let's change the continent where this data was gathered from Antarctica to South America, and we can make that change directly in the spreadsheet view. Another way to make changes is to edit them in the detail panel. We can change the continent back to Antarctica. If we need to make many changes at once, we can use the bulk edit button. We select the sources that we want to change, and then hit the batch edit button. This displays all the possible fields that can be edited. If you want to leave fields as they are, you can just leave them blank. Now, in addition to bulk importing that we saw earlier, we can also add sources one at a time manually from within the program. If you click on the Add Source button, then a new window opens with all the attributes for sources. A unique source key must be given to every source. Some attributes have preset common values, for example, the rock types listed here. We can also enter the GPS coordinates where a source was originally collected. These values are used to populate the Google Maps link that we looked at earlier. Most of the other fields are optional and can be left blank and filled in at a later time. Now when we hit save, we see that our new source has been added to the database. Now let's take a look at samples. As we discussed earlier, a sample can be thought of as a small representative piece of a source for use in laboratory procedures. As you can see, this source just has a single sample associated with it. Samples have three attributes. First, the source key, which is the name of the source from which this sample is derived. Second, the location, which is the current storage location of that physical sample. Finally, a procedures log. As you can see, our fresh sample has had no laboratory procedures performed on it. Suppose the source we are testing is a soil sample. We may wish to do a liquid separation procedure to separate high-density grains from low-density grains. Let's do a 2.9 specific gravity heavy liquid separation now. We also must supply our initials so that a lab administrator can see who performed this procedure. As you can see, we now have two samples, one which was marked as down, which is our high density grains, and one which was marked as up, which is our low density grains. Each of these derivative samples can then independently have other procedures performed. For example, we may do a magnetic separation on one of these samples. We'll see that our other sample has been unaltered, but the one that we performed the magnetic separation on has been separated into two new samples. Now, all this data that we've added is available on our machine locally, but won't be available to anyone else. We should synchronize it now. Since we are synchronizing over 400 data items this first time, this could take a few minutes. Once we have synchronized, any other computer or iOS device running Project Crystal Blue with our credentials will be able to access our data. Let's open it up on our iPhone now. As before, we will need to enter in a local key to unlock our Amazon credentials. Now we'll tap View Sources. There isn't anything there yet, so we must swipe down to synchronize with the database. This will also take a few minutes to download data the first time. Now, you'll see that all our information for our macOS 10 client is visible on the iOS device. We can view detailed information and make modifications to source attributes, just like in the macOS 10 client. For example, let's choose a source and change its rock type. When we return to our source list, we can swipe again to synchronize with the cloud database. Then, when we return to our macOS 10 client and sync, we will see that our changes are pushed. Now, let's return to the iOS client. We've seen how you can add a source from the OS X client. Let's try it from here. This is how you can add information directly while you are out doing field research, even without an internet connection. First, we must enter a key for the source. You must be careful to communicate with your team members to ensure that you are using a unique key. Now we'll populate the rest of the fields. As you can see, on a device with location enabled, you can autofill the latitude and longitude. Since we are using an emulated iPhone, this feature is not enabled. Depending on the type of rock you choose, you may have to enter more detailed lithology and depot system data. Many of the other fields can be left blank until you return to the laboratory and determine more accurately how to fill them in. We can also add images directly from the device's camera. Since we are demonstrating the application on an emulated device, we unfortunately are limited to images already in the device's gallery. By default, the application expects images from far, medium, and near distance of the outcrop. These images can also be left to be filled in later. There is a brief delay here while the images are uploaded. Now let's take a look at our new source in the list. We can see that all the information we added is there, and if we scroll all the way down, we can even view the images for the source and see the picture that we just added. Let's add another picture with the tag close. Now, if we synchronize the sources on the device, we'll also be able to see the images on the Mac OS X client. Finally, let's take a look at how procedures can be performed on an iOS device from inside the laboratory. First, we should choose a source to work with. We'll use our new source. As you can see, there's just a single sample here as well. We'll do a jaw crush on this sample. Unlike the separation procedures we demonstrated earlier, a jaw crush is considered destructive since the entire sample has been crushed. As before, we can combine procedures as well. Let's perform a magnetic separation on this jaw crushed sample. As you can see, two samples have been created, and in addition to the magnetic separation information, both of them also have the jaw crush in the procedure log. This is the conclusion of our video. We hope that this introduction has given a clear overview of some of the features of Project Crystal Blue. If you are looking for a way to organize your institution's geology lab, we hope you will consider Project Crystal Blue as a scalable solution for your organization's needs.